Radio astronomy. What is it? It's defined as a subfield of astronomy that studies celestial objects at radio frequencies. In the 1930s, Carl Jansky made one of the first observations of radio waves when he observed radiation being emitted from the Milky Way galaxy. You might be wondering, what are radio waves and how are they produced? Well, for starters, all matter is made up of atoms, and atoms are made up of subatomic particles, with a nucleus made of protons and neutrons with electrons on the outside orbiting the nucleus. When charged particles accelerate by the changing of their speed or altering of their direction, they emit electromagnetic radiation. Electromagnetic radiation comes in many forms, and all of these forms make up the electromagnetic spectrum. Radio waves are a part of this spectrum. They have a long wavelength with a low frequency, which means low energy. As you increase the frequency and energy, the spectrum will change from radio and microwaves to infrared waves to invisible light to ultraviolet light to X-rays and then to gamma rays. How do we observe these radio waves from space? A radio telescope is designed to receive the radio waves from space. A radio telescope is much different than a regular visible light telescope. It consists of three components if you want to look at it in a simple form. The first component is one or more antennas. These antennas are used to collect the incoming radio waves by reflecting them to a receiver. The antennas that do this are called parabolic dishes, and they behave just like a mirror would focus light to a specific point. Antennas can be more than one shape though. Yagi antennas are similar to the antennas used to get TV reception. Yagi antennas were used in early radio telescopes such as the Dover Heights ones. The second component of the radio telescope is a receiver and amplifier that is used to boost very weak signals. Amplifiers are so sensitive that they have to be cooled to a very low temperature so that there is little interference from the noise of the atoms moving around in the metal. The last part of the telescope is a recorder. The recorder is used to, record the information that the telescope observes. In the old days, the recorder was a chart recorder that drew a graph on regular old paper and ink. But nowadays, recorders record to a computer memory disk since astronomers use a lot of sophisticated software and technology. This picture is of an early radio telescope that was used in Dover Heights in Australia following the Second World War. While the original one is no longer there, a replica stands in its place. The radio telescope in this picture is the Parkes Radio Telescope. It opened in 1961 and is still in use to this day. The antenna on this telescope is a whopping 64 meters across and has been used to find over half of the 1,480 pulsars that are known to us today. This third telescope being shown is the Australia Telescope Compact Array, which is located near Nairobi. Don't know how to pronounce that. There are a total of 6 dishes, all of which are 22 meters and are all spaced out along a rail track that is 6 kilometers. This type of telescope, where there are multiple dishes spaced out, is known as an interferometer. Interferometers allow astronomers to study objects at much finer detail that cannot be achieved by only using one dish. The larger the area used, the fainter of radio signals that can be detected. So what is it that we learn from radio astronomy? We learn an abundance of things about the universe and galaxies from using radio astronomy. While using the traditional optical astronomy is better for observing stars and other planets that emit a lot of visible light, radio astronomy can be used to map out entire galaxies. Since hydrogen is the most abundant element in the universe, astronomers use its characteristic emission of 21 cm to see where there is an abundance of it, or lack of it, to help them map out areas of space. In this image, we can see part of our Milky Way galaxy. The orange in this image represents hydrogen gas, and the dark area at the center is a hole that astronomers believe was hollowed out over the course of several million years. The dark area is said to be roughly 2,000 light years across. A bonus to using radio astronomy is that radio waves are not affected by the dust in our galaxy, thus making other galaxies that lay beyond ours detectable, even the ones that are impossible to see using visible light. Radio astronomy is responsible for the discovery of pulsars, which are rapidly spinning neutron stars that are collapsed cores of massive stars that have exhausted their fuel. Pulsars emit powerful beams of radio waves out into space, kind of like a disco ball, but probably not as groovy. In 1963, radio astronomy was used to find out that object C3C273 was not a star, but rather an extremely bright new object that no one had identified before, which is now called a quasar. They They are primordial galaxies that have supermassive black holes at their centers. They are believed to be the most powerful objects in the universe. This is a picture of the Crab Nebula through a radio telescope, which is located in the constellation of Taurus. The Crab Nebula is the remnant of a star that is believed to have exploded a long time ago. It is currently expanding around 1,000 kilometers per second. This last picture is an artist's interpretation of a newly forming star. The gases that are swirling around it are color-coded, with the red showing speed away from us and the blue showing speed towards us. While radio waves might not be visible, they still play a big part in us learning about the universe.